A tire manufacturer believes that the tread life of its snow tires can be described by a normal model with a mean of 32,000 miles and a standard deviation of 2,500 miles. B, approximately what fraction of these tires can be expected to last less than 30,000 miles? Okay, so what fraction can we, or decimal, can we expect to last less than 30,000 miles? So we're going to find a z-score. The normal model is 32,000, 2,500. So 30,000 minus 32,000 over 2,500, which is negative 2,000 over 2,500, which is negative 4/5. Just 0.8. And so that's normal CDF. We're going to go negative 99, comma, negative 0.8. Right, negative 99 because I'm interested in less than. And somewhere I have my calculator. So 21.2% of tires are expected to last less than 30,000 miles. So part D, estimate the IQR of tread lives. So I need to find 25%, this is Q1, and Q3 is 75% of the data. So I do inverse norm, 0.25, and I'll do inverse norm, 0.75. I kind of want to talk a little bit about using the calculator and not rounding in the calculator, because we really should be rounding on our paper and not rounding until we are done in the calculator. So when I'm doing this, I'm going to set up my equation. Whatever this z-score is, it's negative 0.6745 and positive 0.6745. I'll show you that in the calculator in a second. But my z-score is equal to x minus the mean, 32,000 over 2,500, and 0.6745 equals x minus 32,000 over 2,500. So when I use my calculator, so for the calculator, I'm going to do second distribution, inverse norm. Remember, I'm always going to do the left, so I'm going to put 0.25 in. And then I get this value. So that's where I'm writing down negative 0.6745 on my paper. But now I'm going to solve this equation, but I'm not going to retype anything. Just hit times. My denominator is 2,500, right? 2,500. Enter. Plus my mean, 32,000. It's a lot less work than retyping anything into the calculator. Just use the fact that it'll take, if you put an operation, it'll automatically take the previous number. And then you don't have to round to the very end. Your answer is going to be the most accurate when you don't round until the very end. Okay. Move this here. So I get x equals 30,313.776, because that 5 rounds up. And then I'll do it again. And then, hold on, so I'm going to do it again, but to make my life easier, I'm going to come up here. And I'm just going to hit enter. So you can select something above, hit enter. I'm going to go over here, change this to 0.75. And now I have the positive value of it. And that kind of helps us not have to go through all the menus, but then it's times 2,500 and plus 32,000. So 33,686.22. So X equals 33,686.224. Now I can subtract, and I can even just use the up arrow and do minus, grab the old answer. So the IQR is 33,686.224 minus 30,313.776, which equals 3,372.449. So there's your IQR. So you want to try not to round in your calculator. Don't like type in the rounded number. Okay? Round out when you write on your paper. I don't want to see all 18 freaking digits for every single number on your paper. I had a girl that did that last 1 year. Not last year, it was quite a few years ago. And I was like, honey, you don't have to write them all down. She's like, oh, I like to. And I'm like, but I don't like looking at all those numbers. Like, you know, I mean, her equations were this big because she had like 10 decimal places every time she wrote a number down. I'm like, you can round on your paper. Okay. And then let's look at E. In planning a market strategy, a local tire dealer wants to offer a refund to any customers whose tires fail to last a certain number of miles. However, the dealer doesn't want to take too big of a risk. If the dealer is willing to give refunds to no more than one of every 25 customers, for what mileage can he guarantee these tires to last? So he wants to give a refund to 1 out of 25 customers. 1 out of 25 is 0.04. So 4% of customers he is willing to give a refund to if the tires don't last that long. So what should he say, right, in his advertisement? At what mileage would you get a refund? So we'll find, what is this 4%? So again, inverse norm, 0.04. And it's left, because it's the lower, negative 1.7507 is what I'm going to write down. And then equals X minus 32,000 over 2,500. So I'll multiply by 2,500 and then add 32,000, and we get X equals 27,623.28. Now, do you think this dealer should be like, if your tires don't last more than 27,623 miles, 0.28 miles, you get a refund? What do you think about that?
It's a little unnecessary.
It's a little excessive, right? Like, he should probably round it, you know? Like, no one's going to give that exact number, right? So where do you think he should round it? Do you think he should round it down or round it up? Down, right? If he rounds it down, then that's just a few less customers he'll give away free tires to, right? So he should say 27,600, or even, I would say 27,500. Why? Because people like those like clean numbers, right? They like whole thousands or 500. Like 600 is kind of like, if he said 27,600, you'd be like, well, that's kind of weird. Like if you heard that on the radio, you would be like, that's kind of weird. Why would he say 27,600 and not 27,500, right? Like I went somewhere once and had a speed limit of 13 miles per hour. I'm like, why 14. Like, that is so bizarre.
Wouldn't he sell less tires the more he loses it?
So this is the number in which he's going to say, if your tires don't last this long before they need to be replaced, I'm going to give you a refund. So yes, he'll give a refund to less people, right? Which is good for him. Yeah? It's
Yeah, but, like, if the number is higher, then it's going to take longer for them to have to replace the tires. You know?
so if we round it up to like 27,800, now he's giving away a refund to more people because he's allowing that extra 500 miles before he gives you a refund. Right? So he's saying,
From the consumer standpoint.
yeah, from the
you want it to
consumer
be
standpoint,
higher.
you would want that to be higher, 28,000. If your tires don't last 28,000 miles, he's going to give you a refund. But that's going to make it larger than the 4% he wants to give away to. So we want to round down as we're looking at the seller's, the dealer's perspective. He's going to round down and it'll keep it close to 4%, right? And then he still knows if someone comes in at 27,550, you know, he might have that leeway to say, okay, you know, I'll make this exception for you, where they try to make you feel special, and that you're doing something special for them, right? But he knows that that's his number is a little bit higher than that, you know. So you can see how what we're doing, the math that we do in this class, has more real life application than probably any other math class you've ever taken, right? I mean, you can see, like, we're constantly looking at word problems and situations that, like, businesses have to consider and think about. If they just pick an arbitrary number, they may be giving away too many free tires. So they have to look at data to make better business decisions. And that's what I love about AP Stats, is that you're getting knowledge that you will apply in the world, which is not necessarily true of Algebra 2. Hens usually begin laying eggs when they are about 6 months old. Young hens tend to lay smaller eggs, often weighing less than the desired minimum weight of 54 grams. So your desired weight is 54 grams. This is going to actually be our X value for these problems. The average weight of the eggs produced by the young hens has a mean of 50.9, and we don't know the standard deviation. Only 28% of the eggs exceed the desired minimum weight. So the mean is 50.9, and 54 grams is the desired weight. This area is only 28%. Because it's saying exceeding, so only 28% of these hens lay eggs that weigh more than 54 grams, right? This is why you get your, like, cartons of small, medium, and large eggs, and then you get the extra large. So it's saying, what is the standard deviation? So I need to find sigma. So can I find the z-score?
Yes.
With inverse norm, right? Now, this is a situation where you might use the left center, the right side, right? It's 0.28 right, but if I'm doing left, it's what? 0.72. I have to subtract it from 1 if I want the left. Some of our calculators aren't doing the left or the right. So I do 0.72. And that's left. That is 0.5828. So 0.5828 is equal to 54. That's the desired weight minus the mean 50.9 over sigma. And then we can multiply by sigma. 0.5828 equals 54 minus 50.9 is 3.1 times by sigma divided by 5.5828. So 3.1 divided by that answer is sigma equals 5.319 grams. Okay. By the time the hens have reached the age of 1 year old, the eggs they produce average 67.1 grams, and 98% exceed or above the minimum weight. What's the standard deviation for the older hens? So now we're going to do inverse norm what? 0.02. If I'm using left, I can put 0.98 if I want to use right. Don't forget the 0 too, right? If you put in 0.2, you're getting 20%. So this is negative 2.0537 equals 54. That's the desired minimum weight. 67.1 over sigma. So negative 2.0537 sigma equals 54 minus 67.1, negative 13.1. Oops. Well, yeah, now I'm going to divide by negative 2.0537. And I get sigma equals 6.379 grams. So you might get slightly different answers from what you see in the back of the book. That's all rounding differences, right? And even like the solutions manual will sometimes round throughout the problems. Okay, I much prefer you're going to get closer to the answer I'm looking for if you don't round in your calculator. And you can just, hold on, let me show you tips and tricks with the calculator. Look, how did I get this without typing it all the way in? I went 13.1 and I went up to that number that I want to divide by. And I hit enter. And it's not showing you what I'm showing you. No. All period, I've been trying to show you the calculator. No one's going to tell me we don't see the calculator on the screen, Ms. Wheelock? Not until I push enter here. Come on.
Yeah, then you put a photo up and we all think, oh, look at that thing.
Yeah, no. Well, it will play a video. Jeez, oh man. I forget how to go out of that mode. There it is. I'm so glad I looked up. Okay, so the last question was, are egg sizes more consistent for the younger hens or the older hens? Which one's more consistent? A standard deviation of 5.319 or 6.379? Which one's more consistent?
5.3.
The smaller, right? The smaller is more consistent, so the younger hens have more consistent egg sizes. So for Q1, you did inverse norm, 0.25, which 0.06745 equals x minus the mean. The mean stayed the same, 98.7. And now we want a different standard deviation because we want to talk about the new IQR of 0.5. And so for Q3, I have inverse norm 0.75, which is positive 0.6745. Anybody have these memorized yet? It's just me. I mean, granted, I've been using them for decades. I can literally say I've been using these numbers for decades. And that's why I have them memorized. But good. All right. So how are we going to find a new standard deviation here? I need to multiply by sigma. And then I'm going to add 98.7. Doesn't that equal x, which is really Q1?
Yes.
And then on this side, 0.6745 sigma plus 98.7 is equal to Q3. Now I can take and say that Q3, 0.6745 sigma plus 98.7 minus negative 0.6745 sigma plus 98.7 equals 0.5. Your new IQR, because this is Q3 minus Q1 equals 0.5. And then we can solve that. So this becomes plus and minus. So these cancel, and I get 0.6745 times 2 is 1.349 sigma equals 0.5. Divide by 1.349. So 0.371 is the new standard deviation. Right, so you have to kind of dig back into your algebra and be like, okay, what do I know? What can I do? How can I manipulate these equations to make them equal the 0.5?